Hello everyone. I welcome you all in the another video of daily lead coding challenge. So if you are new to the channel, you can subscribe to my channel. Here I upload daily in-depth video solutions of lead coding challenge, and you can also connect with me on LinkedIn. I've added link to my profile in the description. You can check out the previous problems as well. I've added the link to the playlist, and you can also check out the source code. I also upload the source code of each solutions on GitHub. The link is in the description box. So let us see today's problem. So today the problem is based on some merge sort algorithm. So we are given two arrays, integer arrays nums1 and nums2, and both are sorted in non-decreasing order. What is the non-decreasing order? That means the order is in kind of increasing order, but since the array may contain duplicates, then if I have element 2, then again 2, that will not be considered as increasing order, but we can say that this is non-decreasing order. That's why we say that these are sorted in non-decreasing order. So both are sorted in non-decreasing order, and also given two integers m and n represent the number of elements in nums1 and nums2, right? And we need to merge both the elements present in nums1 and nums2 and return a single array which is also in non-decreasing order, right? And what does this mean? Let us see. So here is the given example. The nums1 is 1 2 3, given m is 3. So the array had 1 2 3 and the size is 3, and it also contain 3 other elements which is not the current element of this array nums1, but these positions are actually empty positions. Basically here it is mentioned that nums1 has a length of m plus n, right? uh, which means that this nums1 has the length m plus n. N is what? N is the length of the number of element present in the nums2, right? The nums2 have 2 5 6, n is 3, right? So the size of nums1 array is number of elements present in nums1 plus number of elements present in nums2. So nums1 can contain all the elements, the elements of itself which is present in nums1 as well as the present in nums2 itself. Okay, so we need to merge both these elements, right? So nums1 is also in non-decreasing order. This is also in non-decreasing order. The final merging would be will look like this: 1, then 2, then again 2, then 3, then 5, then 6. So this should be the final answer, right? And you can see that this is a non-decreasing order. If you see this part of the array, this is in increasing order, but if you include this part, this is, we cannot say this is an increasing order, but this is a non-decreasing order, right? So this is what you need to do. Okay, so one of the way could be like and also what we need to do here, we have to store this merged array into nums1 itself. We do not have to return anything. Okay, return type is void. Here it is mentioned that the final sorted array should not be returned by function, but instead should be stored inside nums1, right? So this is called in place. When we use the same space as provided in the problem statement, we use the same space to store our answer, then this is called an in place. Otherwise, if we use an extra auxiliary space, we create another data structure to store some data and to store our answer, there we'll be taking extra space. That is called, that will be not an in place algorithm. But here everything has to be done in place. We need to return nums1, the final sorted array into nums1 array, right? Okay, so what we can do, one of the way could be like we will do a merge sort. So let me explain you first of all what is a merge sort. So merge sort is an algorithm. If we have given like n number of array, let us just consider two array. Let's say the first array had only this much size, it has 1 2 3, and the second array has 2 5 and 6, right? So I'll start looking from the very first index of these array, right? And this is the final array where the merged elements will be placed. So I know if I am at the first position of this array, this would be the smallest element present in this array. Similarly, if I'm at the first position of this array, this is the smallest element present in this entire array, right? So I'll compare the smallest element of both these arrays. So whichever the small among these two, that would be the smallest among all the elements currently I am at. If I'm at here and this element is smaller than this element, then that means this element is smaller than all the elements in this array and as well as in this array, right? So I'll pick this element, put in this answer array. And since I'm done with this element, I'll increment this pointer. Now I have come here. So looking at this element, I see that both elements are equal, right? So which element I should pick? I can pick anyone. Let us say that we pick from this array itself. So, okay, I'll take this element, fill this result array and move this pointer. Now again, I'll compare these smallest element. Right now, the smallest element in this array, which I have to look is 3 because 1 and 2 has been done. And in this array, the smallest element which have to be looked is 2. So I'll compare both of them. This is smaller. I'll pick this and put this in this array and move this pointer. Again, compare. Okay, so 3 is less than 5. So I'll put 3 here and increment the pointer. Since here there is nothing to compare now, I am done with all the elements of this array. So I'll simply put all these elements in the order as it was placed here. So this should be the final answer. This is called a merge sort. So we can also do the same thing in a reverse order. So let's say this was 1, 2, 3. This is 2, 5, 6. This is the final array. So what does reverse order means? I'll start from the greatest element in both the array and start filling this final array from the last index. So this last index will contain the greatest element amongst these two arrays, right? So right now I'm at the last index of both the arrays. So that means I'm at the greatest element of the first array as well as greatest element in the second array. So I'll compare greatest element in both the array, and whoever the greatest element among these two will be the greatest element among all the elements in both the arrays, right? So I see that 6 is the greatest element, so I'll pick the 6, fill this and decrement the pointer. Then compare 3 and 5. 5 is greater than 3, then I'll put the 5 here and then again move this pointer to left. And then compare these two. 3 is smaller, I'll fill here 3 and then move the pointer to left. Compare 2 and 2. Let us do the same. I'll just pick from, I can pick from anywhere. I'll pick, let's say I pick from here. I'll fill here 2 and then move this pointer again. And let's say 1 and 2, then 2 is greater. I'll put here 2 and move this to the left. Here now there is nothing to compare. I'm done with all the elements of the second array. Now this is the only remaining element. I'll put the element of, or let's say it had something like the 0, 1, then I would have filled all the element as in the same order at it, as it was here, right? So you can see the answer is still same. So both, in both ways we can do the thing, right? Now we can also do the same thing here because we have been given two arrays, right? First array had 1, 2, 3, then 0, 0, 0, but we only need to consider these elements and these elements, right? So in the similar manner I can do here as well. In the given problem, I'll create another array, okay, and then I'll fill this array, right? So definitely we can do that, but if we were allowed to do that, then the return type should not be void. There should be something else we should do, because if uh, if we were allowed to do that, then we could have returned just an integer array, a new integer array. But it says that the return type is void. That means we should not return a new array, right? Rather, we should do the computation in the same array, and here as well it has mentioned something like this. Now you will say that because question says that we need to store the final answer into the nums array. So we can do something like this. We'll create another array of size order of size n plus n basically. I'll create another array. Let us say that this is a temporary array. Initially, I'll fill this array. Then finally, I'll fill nums1 again from this answer array, because this is in the non-decreasing order, then I'll start filling these elements in this manner, right? And then in that way, the final answer would be reflected in the nums1 as well. But this is not the intention of the problem. If this was allowed to do, then what is the problem in just returning this array itself, right? So here we need to think something else, right? So what we need to do, we need to fill this nums1 array, right? So let us see how we can do this, how we can achieve the desired goal. Second array was 256, right? So we need to fill this, right? So if I compare the smallest element of these two elements, so this is the smallest element. Okay, that is fine. Move ahead. Which is the smallest? So both are equal. I'll take this one, move this ahead. Which is the smallest? This is the smallest element, right? This is the smallest element. So this should come at this position. What about this element then? If I simply put this element at this position, then I'll lose this information that what was the element at this position in nums1. So first of all, what I need to do, I will have to shift all these elements to one position towards right. So this 3 will be shifted to here. If there was some element at this position, it would have been shifted to this position. But here there's no element, so there's just a one shift required. And then I'll place 2 here, right? And let's discuss one more thing. I forgot to discuss here. When we were doing a merge sort, what we are doing, we were just iterating over these elements and picking the smallest among them and then filling this in this array. In this way, I was iterating, I was doing a single pass on this array and as well as in this array. So this array had a size m, this had a size n. So the total complexity of merging these two arrays was order of m plus n, right? So now let us see what the complexity will be here in this way. If I merge these two elements in this array and by shifting these elements, right? So, okay, now I have placed 2 here, move the pointer to right. Now, okay, I've also picked 2, so move this pointer as well to the right. Now I'll compare 3 and 5. So 3. This 3 is the smaller one. This should be the correct position for this. So no need to uh, move anything, just let it stay here and move the pointer to the right. Now, since we are done with all the 3 elements for the first array, simply copy the remaining element in the second array. So here it is 5 and then 6, right? So in this way, we can do this. But let us take another example. Let's say we have something like this. 1, then here 2, then here 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, right? And then the rest of the element, like it will be 0, 0, 0, right? Basically, this array has only these elements, and this has these elements, and this is the extra space remaining, which is of the size of number of elements present in num2, right? So let us do the same thing. We have what is the size of this array? 1, 2, 3, 4, 5. 5 these elements and then 5 these elements, right? So the size should be 10. This is nums1, right? So it is 1, 3, 5, 7, 9, and rest is 0. Right? 5 zeros. This is nums2. And this is 10. Okay. So right now I have to deal with m elements in this array and n elements in this array, right? So to deal with m elements, if the first element is at index 0, that means the last index which I have to see in nums1 will be m minus 1 index, right? Because it has m elements and the first element is at index 0. So if if I reach at m minus 1 index at some point of time, I'll say that, okay, this is the last element. If I move one after this, that means I have seen all the elements in nums1. Okay, so at m minus 1, the last element is present. And in nums2, at n minus 1, the last element is present. Okay, if at some point of time my index value, which using what I'm iterating over this array, becomes equals to n, that means I have iterated over all the elements, right? Let us iterate on nums1 with I index and on nums2 with j index, right? So let us compare both these value. So also let us mark the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so initially the I value is 0, j value is also 0, right? So compare I0, J0, compare these two. So 1, 2, right? Compare these two, 1 and 2, which is the smaller one? This is the smaller one, okay? And we have one more position, let's say POS, which tells that at which position I am filling, right? So see, which is the smaller one? This is the smaller one. So at 0th position, I need to fill from nums1. But since nums1 itself, because nums1 is the array where I need to put the answer, and this element is already present in nums1. I do not have to move any element. Okay, I'll simply increment I will become 1, right? And j will be here because we have not placed this yet. Now compare these two elements, which is the small one, 2, 1, 2 is the smaller one, right? So 2 is the smaller one. So 2 should come at this position. But if I simply put, okay, I forgot to mention, we also do position plus plus because last position has been filled. Now we have to fill the next position, which is first position. So now I compare 3 and 2. I see that 2 is the smaller element. So 2 should be filled at this position. But if I directly put 2 here, I'll lose this information that this nums one had a 3 at this index. So what I am doing, I will be shifting all these elements towards right? So what is the time complexity in shifting all the elements? Because right now I have to shift m minus 1 element. So the time complexity will be m minus 1 first time if I'm shifting, right? So here I'll shift this 9 to here by one position. Then here it will be 7, here 5, here 3. Now I have shifted, then I can simply put here 2. Then I will do a j plus plus because I'm done with this element. The j will come to this index and I plus plus because this is the next I which because we have shifted the element to a one position. So I need to compare at I plus plus because I've shifted the element which was at I plus 1. So that's why we need to also update I. And since we have filled this position array, I'll also implement this position. Now compare these two elements. So which is the smaller one? This is the smaller one. Then again, move this I to the next index because no need, because it is already present in the enums one. Compare the next element. So I plus plus, do a position plus plus, which means fill the third position. Now again, we'll be comparing 4 and 5. 4 is the smaller one, but again we will have to do the same thing, shift all the element towards right. Then there are m minus 3 elements, so we'll be shifting these m minus 3 elements, right? So if I do merging in such a manner, what is the complexity I will be taking? Here, it was happening that in one case, for one value, I was taking a minus 1. For another value, I'm taking a minus 3. But in the worst case, it might happen that, uh, in the worst case, it might happen that I will take every time I'll shift all these elements. Let's say this array has 5, 6, 7, 8, something like this, first array, and the second array has 1, 2, 3. So for the first element, I'll shift these all m elements, right? For the second element, again, I will shift all these elements, right? If you visualize something like this, if I'll fill this index, for this index, this element has to come here. So I'll shift all the elements. So here 8, here 6, here 7, 6, here there will be 5, and here it is 1. And I'll be at this index. Then again, here is 5, here it is 2. Again for 2, I'll shift again. So for all these n elements present in nums2, I will be shifting all these all the element present in nums1, which take order of m times. So in merging, in doing this for all the elements, because for the single element I take order of m time in shift all the m elements, and for the n elements I'll take order of n into m time, but I need to solve the problem in order of m plus n time. Okay, so I cannot do something like this. So what is the issue? The issue is that because I'm filling the smaller elements, and since nums1 present elements in the starting indices, right, then I'm also putting the elements in the starting index. So this is the problem, because the nums1 is filled from the start index, and while merging I'm also filling the end start indices. That's why there is a problem that I will override some of the value which I have to use in future. So what we can do, since nums1 contain elements from the starting, what we can do, we can start filling nums1 from the last index, right? In that way we will not be overriding the already present value in nums1, right? If this element and from in order to fill this nums1 from the last position, what we need to do, we need to merge both the array on the basis of taking the greatest element, because this last index will contain the greatest, right? So if we do filling something like that, then we will not be overriding these values. So let us understand this further, and you'll get a more clear idea about this what I'm saying. So the array was 1 2 3 and 2 5 6. It is 1 2 3 and 0 0 0 and 2 5 6, right? So initially I'll be filling at this position, right? So what elements I will be comparing, this element and this element, right? So see which is the greatest element. 6 is the greatest, so I'll fill here 6, right? Let us make these positions empty instead of 0. This all are empty. There are 3 vacant positions. So here I'll be filling 6 and then decrement this pointer. Then again compare these two elements. So 5 is the greater element among these two. Fill this position with 5 and move this to the left. Which is greater? 3 is greater. Then fill here 3 and move this to the left. Now see that if I have moved this pointer to the left, that means I've already processed this value. I've put this value somewhere in the right side of the nums. That means now this position is free to use. I can overwrite anything here. But what I was doing here, if I was filling from the starting array, if something was coming from this position, then it was overriding this element. And to prevent that, I was shifting all these elements towards one position, right? And then I was freeing this element, this position. But here, what is happening? If some greater element, so if a greater element is coming from the second array, then there will be a vacant position always, because there will be always n positions empty, right? So whenever an element is coming from this index, there always be a position, there will always be an empty position, right? Because if I'm filling from the last index, there will be always n vacant spaces, right? If there are n element which I need to process from the second array, there will be n vacant places. See from the starting condition, when it was 1 2 3 and dash dash dash, and here 2 5 6, right? So these 3 positions are empty, and I need to fill these 3 elements as well. If this was it, if 6 had, if I have got the element from the second array, then I have 2 empty position, and here in the worst case I have to fill 2 elements only, which is also equal. I will never override these values, right? So in the second pass, what happens that 5 comes here, and the size is for the nums2 is 1, and still I have one vacant position. And then we see that the 3 is the greater element, so 3 should be put over here. So I put 3 here, and this position get vacant, right? Still I have one single position vacant. And then to compare these two, even if I fill this one, if I take this element, I'll put this element at this index, and this element, this position will be vacant. So in this way, I am always preserving the vacancy for all the elements. I'm not overriding at someone other's place. If I'm picking from this array, if the greater element is coming from this array, it will always have a vacant place and it will fill that index. or if the greater element is coming from that index, it will occupy the space, vacant space, and it will create a vacant space where this element can reside, right? This is what I am doing if I am filling the array in such a manner, and that is an accepted solution. In that way, what I am doing, I will be only processing the number of elements in the first array and in the second array. Okay, nothing more than that. I am just placing, I'm just comparing the value and I'm putting the value and move the index to the left for in the array who from where I have taken the value, and then compare these next values. Then again, I just decrement the index. So in that way, when I am done with both the array, when both pointers comes here, then I'll stop. So in that manner, I am only iterating over these elements. So the time complexity will be m plus n, and I'm filling in the same array nums1. So I'm not taking any extra space. So space complexity is order of 1. And if the time complexity is m plus n, that means the number of operations will be, since mn will be just 200, so m plus n would be 400. And even it has said that m plus n in the worst case will be just 200 even. Okay, so the code is going to be very fast if we solve the problem in m plus n time. So let us solve, let us do this. So I say that let us code this one. So this was 1 2 3 1 2 3 and then 0 0 0. It was 2 5 6, right? So this is the last position from where I need to fill. So let us say I create a variable POS, which is m plus n minus 1, the last index which I am filling, and the last element in the lumps one will be this one, which is because it has m elements, so I should be equals to m minus 1, right? Pointing to the last greatest element in the nums one. So I should be equals to m minus 1, and similarly j should be equals to n minus 1, right? Then what I have to do, while I is greater than 0 or j is greater than equals to 0. What does this mean? This means that there's still a element to process either in nums1 or in nums2. Till then we need to start, we need to fill this array, right? So we'll again check if it happens that both the array has, if both the array has elements, at least one element to process. So we need to compare if both the, if I is greater than equals to 0, j is greater than equals to 0, that means both arrays has at least one element to get filled. So that means I can compare, I should compare both these elements. So now if it happens that nums1 of I is greater than equals to nums2 of j, so in that case, since nums1 has a greater element, or it might have, it might be equal to jth element, in that case I'll fill nums1 of position to nums of I, right? And we need to do I minus minus as well, right? Which means that if I'm taking an element, if I'm taking an element, let's say I was comparing, let's say I was comparing these two indices. If I'm taking this element, then I should also come to the left. That's why I'm doing I minus minus here. So what I minus minus will do, initially the value of I is here is 0 1 2. So nums of 2 will be put here in the nums of position, and then I will also decrement to the I will be equal to 1 after that. But if it is not the case, that means nums j contain the greater value, then I will be doing nums1 of position is equals to nums of j minus 5, right? But it happens that both these conditions are not true. Either I is not greater than equals to 0, that means I is negative. If I is negative, that means I processed all the elements in the nums1. But it might happen that because this loop is also true, that means one of the condition is true. If this was false, then this position might be true. So I will check else if happens that j is greater than equals to 0. If this had at least one element, so there is no comparison. This is the only choice which I have to fill. I'll fill nums1 of POS as nums of j minus minus. Okay, but it happens that j was negative, but I was not negative. What does that mean? I'm done with all the elements in nums2, right? There's nothing to process in nums2. Only the elements which need to process are in nums1. Then why do I need to compare? It is already filled in a non-decreasing order, right? And up till here, all these are not in non-decreasing. So I should simply break out of the loop, because the rest element which I need to process is already present in this nums1 array itself in a non-decreasing order. So I just break. But let's say if this condition was true, then none of these will be checked, and I need to do position minus minus, because this current position has been filled and we need to fill the left position now. We'll go one left, right? So let us check if this is working. Okay, unable to find the symbol. No, okay, it should be nums2 of j, should be nums1, should be nums2. This should be nums2. Okay, this should work now. Working. Just check for some other values. When the size, here the size is 0, size is 1. Here the size is 1, this is size 0. So both these conditions have been checked. Okay, check for this. Okay, getting, let us submit this solution. So the solution is getting accepted, and I hope you have got the solution. If you still have some doubt, you can mention them in the comments. I hope to see you in the next video. Thanks for watching.